Welcome back. We're now going to do the second of our investigations into momentum. This is the momentum collisions, which is in dealing with elastic and explosive collisions. In our previous investigation, we used this applet here, and we used the inelastic collisions, but this time we're going to be using the elastic collisions. So what is an elastic collision? Well, there are various degrees, and I'll run through them with some in a few more moments. But an elastic collision generally is simply where we have, let's just do some here, we have two carts colliding. Oops, let me stop the show. And they bounce off each other in different directions, and they do not join together. We have different levels of, I'll just reset that, let's try it again. So let's restart. So here the two carts come together, they bounce, and then they return. Okay, so they're not sticking together, which is an inelastic collision. Right. So what and how do we determine an elastic collision? Elastic collisions, elastic, coming all the way in a bit of a spectrum. There is pure elastic or purely elastic, all the way to mostly elastic. Okay? Now, purely elastic collisions, remember elastic collisions where two objects interact and then they collide and then they bounce off each other. In a purely elastic collision, no kinetic energy is lost. Now, what means that? It's not energy, it's kinetic energy. In other words, there's no conversion of energy into sound or heat. So this is very unlikely. Normally when two objects collide, we always hear sound, we always have some heat generated. This is a theoretical, and it's a theory only, because we really can't have this happening. Okay? There are times when we can try and make it nearly purely elastic. So in this case, we have absolutely no kinetic energy is lost because none of the energy during the collision is converted into heat or sound. Most elastic collisions, that's when they come together and bounce off, are mostly elastic. That means that some kinetic energy remains, plus you get sound and heat. Okay? Energy in all cases must be conserved. That's energy, that's the total energy must be conserved. But in a purely elastic collision, kinetic energy is conserved. And that's a very rare event. Okay? But today we're going to be looking only at these elastic, mostly elastic collisions, and we're going to also just be looking at the momentum of these collisions. We'll look at the kinetic energy of these collisions at a later stage. So in this simulation that you're going to be running through, there are a few simulations that we're going to do. We have the initial conditions set in each of the rows here. I remember once again, I have created here as the first one to help you along, and then you can do the second part. So having a look here, the masses and velocities. So I need you to set the red cart to 3 kilograms and the blue cart to 2 kilograms. Okay. Then I want you to set the velocity of the red cart to be 5 meters per second and the velocity of the blue cart to be 5 meters per second. Right, now before you set the simulation going, we can calculate the initial momentum. That's rho I. Remember, momentum is mass times velocity. So mass times velocity is 15. Since this is a plus 5 velocity, this is a plus 15 Newton per second there. The mass of the blue cart multiplied by the mass of the velocity of the blue cart is 2 times negative 5, so it's negative 10. To get this, so that's the total initial would be 15 plus negative 10, and that will give us 5 Newton seconds. So the initial momentum is 5 Newton seconds. What you now need to do, since these are being set onto your, let's go back, we set those onto our, oops, let's go, set this onto our applet. So we have 2 kilograms there for the red cart. Oops, 2 kilograms. I can't get it to move. So I'll reset it, I think. 2 kilograms, and I'm just going to go back. Sorry, it's 3 kilograms and 5. 3 kilograms and 5 meters per second for the red cart. And the second one is 2 kilograms and -5 for the blue cart. So it's 2 kilograms and -5 for the blue cart, which is already set there. Okay. You then run your simulation, and then you can work out what is the final velocities of the red cart. The red cart is -3 meters per second, and the blue cart is +7 meters per second. You can add that now into the table, into these 2 positions here and here, and then calculate momentum of the red cart after the collision and the momentum of the blue cart. And by adding these together, we can get a final momentum. Okay? We should know that since momentum is conserved, these 2 numbers here should be the same. Okay. After you've done a few simulations, then there is a simulation on explosive collisions. So have a go at finishing off this one as well. Okay, good luck.